I got this feeling inside my brains. It goes electric wavy when I make them A's. All through 4th grade, all through my school, we're flying up no ceiling when we're in our zone. I've got that sunshine in my pocket, looking forward to a good day. I feel I can do everything when I try. I can't stop myself from learning, moving up academically. We'll unlock the way we rock it, so don't stop.
Hello everyone and welcome back to day 3 of learning about identifying triangles. Okay, so today we're just gonna go do some practice problems. We're gonna see what you learn, what you know, what you don't know, so that way we can get some practice in. Okay, let's get started. Okay, so today's TEKS is 4.6c, identifying triangles, and we're gonna apply this knowledge of right angles to identify acute, right, and obtuse triangles. Okay. Our learning goal or objective for today is students will know how to identify different triangles. Students will understand how to describe the difference between the triangles. Students will be able to share in a group discussion how to apply knowledge of right angles to identify acute, right, and obtuse triangles. Okay, let's go ahead and look at this video. I think it's a really good video too.
So a stadium bears loads just like a regular building, but unlike a regular building, you can't have a lot of beams to support the roof in the middle because that would obstruct the view, which is the whole reason why you go to a stadium, other than the hot dogs.
You have to design such that you know where the forces are going and how to direct them.
The University of Phoenix Stadium actually employs Brunel trusses. This is a kind of structure that really supports the stadium's roof using an arch that's formed of a lot of triangles to bear the load.
Let's examine the strength of triangles. Rectangles, when subjected to force, easily collapse into rhombuses, but a triangle distributes force down its sides and maintains its shape.
So take this triangle and start tilting it and trace where the tip is. And what shape does it make? An arch. So the strongest point of an arch is almost every point along its curve. And if you want to support that, just add more triangles.
Your trusses will be made of solid steel. Each will measure 700 feet long, 87 feet high, and 17 feet wide, and weigh 3.6 million pounds.
I can't even fathom how many donuts that is. Everything is measured to me in donuts, so it's a lot of donuts.
Wow.
This technology bull market has been
Awesome. So triangles are the strongest structure out there to build stuff. Isn't that amazing? That's so cool. So some vocabulary that we're gonna get to, and I'm just gonna go through this really fast because we've learned a lot of the vocabulary, so it should be in your notes, but that's why I'm just gonna go over it really fast with you. Okay, so angle, which is two rays with a common endpoint, which is called the vertex. We have a right angle that's exactly 90 degrees. Oh, you can't see me. A right angle that's exactly 90 degrees and it has a little square. Okay, we have an acute angle that measures less than 90 degrees. We have an obtuse angle, an angle with a measure of greater than 90 degrees because it's big. Then we have the right triangle, which is the largest, the largest angle in there is a right angle, so that's why it's called a right triangle. We have an acute triangle, which all three angles are acute, less than 90 degrees. We have an obtuse triangle, which the big angle in there, the largest angle, is a obtuse angle. Okay, let's go ahead and check for our understanding. Check for your understanding. What is this? Is this a right triangle, acute triangle, or an obtuse triangle? Go ahead and fill in your answer in the bubble. I'm just kidding. Go ahead and tell me. Okay, you think it's that? Let's check. Correct, it's a right triangle because it has a right angle. And you could tell because it makes an L and it has a little square. What triangle is this? Right, acute, or obtuse? Go ahead and let me know. Good. Oh. It's an acute triangle. Next one. Right, acute, or obtuse? Perfect, obtuse. Ooh, now it's not. Now they're real pictures. What do you think this is? Good job, right, because it goes up and down and across. And even though it doesn't have the little square, this is where the square would be. It forms an L. It's an upside down L. Ooh, what do you think this is? Pizza. Oh, I'm hungry. Actually, I was cooking food. While you're looking at that and seeing what that is, I'm gonna go get my food. Alright, I'm back. What do you think it is? Acute, good job. There's all three are acute. Next one. Ooh, the triangles in these things. What do you think they are? Acute, good job. Look at that. Excellent. Ooh, the triangle in the hangers. The triangle in the hangers. What do you think they are? Obtuse. Good job. Obtuse. Look at that. That's a big obtuse angle right there. Ooh, the pyramids. What do you think that those are? Acute. Good job. Okay, we're gonna do some more practice. We're gonna do two more and then that's it. Okay, which statement is true about the two triangles? Okay, so let me just move myself a little bit. Okay, so where do you, about these two triangles, what do you think? A, both triangles are obtuse. B, both triangles are acute triangles. C, neither triangle is a right triangle. Or D, neither triangle is an obtuse triangle. I'm gonna give you a few seconds to look at that. All right, let's see then. D, neither triangle is an obtuse triangle. Good, because this one is what? A right triangle because it has the right there. And this one has what? Acute. Good. So neither one are an obtuse triangle because none of them have an obtuse angle. Good job. Last question. Parker describes a triangle to his neighbor. He gives the following description. Okay, so he's telling his neighbor, hey, I'm gonna tell you a triangle. This is what it looks like, okay? It has one angle that measures 80 degrees. It has two congruent sides. It has two angles that each measure 50 degrees. What type of triangle is Parker describing? Okay, let's look at our answer choices. Obtuse, right, acute, or it's a circle. Which one do you think it is? Okay, well, it's not a circle. We know that, right? Good. Okay, let's go ahead and look at this. So one angle measures 80 degrees, okay? So is that more or less than 90 degrees? Less than 90 degrees, but close, okay? So something like that, so that's our 80. Okay, and let's close this up. Two sides are congruent, okay? This and this side are congruent. And it has two angles that have measure 50. So I'm put the 50 out here. 50. 50. What type of triangle is Parker describing? Okay, what do we know? Well, let's look at the obtuse. Is there an obtuse angle in here? It has to be more than 90 degrees. Is there? No, correct. Right angle. Is there a right angle in here? It has to be 90 degrees exactly. Is there? No. Good. So, and my largest angle is 80. So that means that it has to be an acute triangle. Good job. Look at that. All right, that is it for today. I'm gonna leave you with one question and you this. Good job, acute. You do this one by yourself, okay? Go ahead and copy this down as your exit ticket and make sure you write this down. A equilateral is broken into 3 triangles. A quadrilateral is broken down into 3 triangles. Based on the angles on the angle measures given, what type of triangle is the shaded triangle? What type of triangle is a shaded triangle? I'm assuming the one in the middle. Okay, so this one. What type of triangle is this called? They gave you an angle. Acute triangle, obtuse triangle, right triangle, it's a square. What type of triangle is this called? Go ahead and write this down in your notebook, and I'll see you next time for our next lesson. I hope you have a good day. Bye.